Welcome, this is Algebra 1, Semester 1, Unit 2, Lesson 2. Today we're going to be solving linear, that means x to the first power. Inequalities, that means we're going to now look at the greater than or less than signs. Or this is actually less than or equal to, and this is less than. I know that because it fits in my left hand. You guys know my weaknesses? Yeah, you know why I tell you that. This is greater than, and won't fit in my left hand. It's greater than or equal to, and then this is greater than. Okay? So let's look at the first problem that they're going to put your way. Actually, they're just wanting you to discover something here. They say 4 is less than 5. Well, we know that because on the number line, 4 is here, 5 is here, and the less than always goes to the left, so we know that is correct. So now they say, well, multiply each side by 3. By the multiplication property of equality, and here, since it's an inequality, it would be inequality, we know that we can multiply each side and keep it constant. So 4 times 3 is 12. And 5 times 3 is 15. And so we discover 12 is less than 15. Okay? Well, now we want to look at a little thing that happens if we happen to multiply by a negative. 4 times negative 3 and 5 times negative 3. 4 times negative 3 ends up being negative 12. 5 times negative 3 ends up being negative 15. If this were correct, then our number line, way up here at 0, would count down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, negative 12, 13, 14, 15, there we go, negative 15. We have a problem here, don't we? Because it should be going this way, and it's going that way. So we actually have something that we have to really watch in these kind of problems with inequalities, is anytime you multiply by a negative number, you have to flip that inequality sign. Because what's happening is you're taking this number and you're going negative direction this many times that, so you're farther from 0 than that many times that one because it was smaller. So originally this one smaller than that one, but when we multiply by the negative, we have to flip it around because this one ends up closer up here than that one. Okay? This also is the case for division. So nothing real new today in solving these problems. Just like yesterday, I expect you to draw the line where the equality is, or inequality, and we go up our PIMDAs. First rung is add, subtract, so we circle our creepy dude and we say what's being added or subtracted to him. Negative 5. So we add 5. What you do on one side, you have to do the other. That would be the addition property of, be careful, this time it's inequality because of the inequality sign. This cancels, we get 3x is greater than 9. Okay, now we're done with add, subtract. Creepy dude's still circled. He's being multiplied by a 3, so that tells us to divide by 3. And we find that x is greater than 3. When we plug it back in, 3 times 3 is 9. And I paused for a minute. I thought that I had done something wrong. I thought that I left out the equality sign. But 3 times 3 is 9. Minus 5 is not greater than 4. So 3 is not a part of the solution. That's why there's no equality sign underneath it. You would have to choose a number bigger than 3 for this to work out and be true. Okay? Whoops, we forgot to justify those. So that was addition property of inequality. This one, look at what you did on each side of the equation. You should write division property of inequality, and then circle your answer. Okay, on this problem, same problem, but I wanted to throw a -3 in here. Right there, just to throw you off. So, draw the line, not to throw you off, but to show you. We go up the PIMDAs. Add 5 to each side, because that's what's being added or subtracted to the x. That wipes out. We get -3x is greater than 9. Now we need to get rid of that multiplication, so we divide by a -3. Hopefully you remember from the first problem, anytime we divide by a negative, we flip this sign. So x now has to be less than -3. Write in your properties. This would be addition property of inequality. This would be the division property of inequality. And circle your answer. So in order for this to be greater, we have to have an x value less than -3. This time let's try one that does work. Let's think out our number line. Here's 0, here's -3, 1, 2, 3. Let's go with maybe -4. -4, just writing the original problem again. I think that was a 9 in the original problem. I made it 4 this time. Okay, so -3 times -4 is +12, minus 5 is 7. 7 is greater than 4. So we're good. Okay. Oh no! The teacher in me comes back out. Hey! Represent those! If you get x is greater than 3, you need to show on a number line that's got a number of, you could actually skip up like that. I'd like you to put 0 in there just so I know where you're at. This would be an open circle because it didn't contain the 3, remember? And it's all the numbers greater than 3. So I want you to show me that beside that answer back in your notes. On this one, number line, 0, -3, open circle again, and it's everything that way. Notice the arrow tips always match the inequality, and it's always open circle if they don't have an equality under them. If you had an equality like this, you would draw it this way. If you had an equality like this, you would draw it this way, okay? Why should you do that? Because you need to show me what your answer number set is. Just like when it was equals, you told me what answer would work. You put x equals a specific number. These have a range of numbers, okay? So have a good day. I'll see you in class.